All right, so we are recording, this is the recording for the Unit 4 review. Let me just zoom in so we can have a little bigger picture, and here we go. So starting with page 1, and page 1 is, both of them are graphs. Question number 1 and 2, one of them is an exponential graph, the other one is the bottom one is a log graph. So exponential graph, it's first asks for the parent exponential. Parent exponential is always the, you have to look at the base, so it's just y equals base is 2 to the power of x. It's as simple as that. No transformation is taking place. So, but then ask for the transformation. So how does it go from here to here? It's x plus 2. That means it's moved 2 units back, because horizontal is always in the opposite direction. But the vertical stays the same, so 3 units down. And the asymptote, this is an exponential function. Exponential function has horizontal asymptote. So horizontal lines are always y equals 2. So you're looking at the y shift, which is -3. Things like domain, range, and all of this, I like to fill up after we do the graph. It's easier to see it with the graph. So let's go ahead and fill in the table of values that will help us plot the graph. So remember, it's an exponential graph. You always start off with, there are two tables to be taken care of in the exponential graph. One is you do the parent exponential. That means you do for 2 to the power of x, and then table number 2, you do the transformation. So that's step number 2. So there are 2 steps to creating the table. So first table, when you do the parent exponential, it's y to the power of 2, y equals 2 to the power of x, and I take 3 x values, -1, 0, 1, and 2 to the power of -1 is half. 2 to the power of 0, anything to the power of 0 is always 1, and 2 to the power of 1 is 2. And then my second table, you transform, so you look at the x and the y transformation. X is moved, it's x plus 2, but it's actually moved 2 units back, so it's x minus 2, and it is y minus 3. So what does it mean? That means you're going to look at all the x values and subtract 1 from that. So this one is going to be -1, x is -1, minus 2, so we're looking at -3. 0 minus 2 is -2, and then the last one is 1 minus 2, which is -1. So -3, -2, -1. And the the y column is y minus 3, so my y is half. So half minus 3 is negative, because it's basically 3 minus half, it's just 2.5, except it's -2.5, because 3 is negative, the larger number is negative. So that's 1 point. -3, -2.5. And then the next one is y minus 3. 1 minus 3 equals -2. And then this one is y minus 3. So this is 2. 2 minus 3 is -1. So these are my 3 points. So let's see how we're looking at this. First of all, you want to draw your asymptote. Asymptote is y equals to -3. And let's plot the 3 points. -3 is -2.5, somewhere here between 2 and 3, and then -2 is -2, -2 is -2, and then -1 is -1. So basically on this side it will hug the asymptote, on this side it will keep going. Okay, this shouldn't have been touching this. This was my mistake, but this is how the graph is going to look like. Let's go ahead and look at the domain and the range. So domain is x-axis. So on this side it goes on forever, and this side also is going on forever. So it's -infinity to +infinity. On the range side, my graph doesn't start till -3, and -3 is not included. So -3 with parentheses, and it goes on forever. You can see that. Now let's do the limit. Limit is as x is going towards infinity. So as x is becoming bigger and bigger, what's happening to my graph? The graph is also growing, and there is no limitation. So it's becoming bigger and bigger. So this will be infinity. Then let's look at as x is going towards -infinity. As x is going towards -infinity, what's happening to my graph, to my y value? As we're going towards -infinity, it's dropping down, but it is tapering off at -3. There's a limit at -3, so this is at -3. And there's no decreasing. the whole way it is increasing, right? So this roller coaster is only going up. And remember, increasing, decreasing, you read the x value. So this is negative infinity to positive infinity. So that's your first graph. This is an exponential graph. Okay. Now let's look at graph number 2. It's a log graph. F of x equals 6 plus log base of 2 of x plus 2. What you need to understand is this 6 is nothing but the vertical shift because it's not a part of the log term. It's outside. So they've just kind of, as a way of writing, instead of writing a plus b, they've written b plus a. So I'm going to rewrite this in the way that we're used to, log base 2 of x plus 2 and then plus 6. So this is the way that we are used to, and that's why I rewrote it in this form. My parent, so this is a log function, but remember, even log functions, you need to know the parent exponential function because my table starts with that. My base is 2, so it's 2 to the power of x, and my parent will stay as log base 2 of x. So I hope everybody understands what's parent exponential and parent log. What is the transformation taking place? 2 units back, because it's plus 2, but it will go back, and 6 units up, plus 6 and 6 units up. Okay, asymptote. This is a logarithmic graph. So remember what we have talked about? Logarithmic graphs have vertical asymptotes, right? Logarithmic graphs have vertical asymptotes. Vertical lines are always x equals to something. They're always x equals to something. So x equals to, right? Vertical lines always go through some x point. And then you're looking at the x shift. Even though it says x plus 2 on the x-axis, it's moved 2 units back. So it's x equals to negative 2. So you should be looking at this. Okay, now let's go ahead and fill in the table. So unlike in exponential where there are 2 tables, the logs have 3 tables. Table number 1 is the parent exponential. Table number 2 is parent log, which you get by switching the first table. And table number 3 is transformation. That means you will transform the log to the new transformed one. Parent log will get transformed. So let's go ahead and see the parent exponential. This one same, negative 1, 0, 1. Y equals 2 to the power of x. Same, half. Anything to the power of 0 is 1 and 2 to the power of 1 is 2. And then for you to do the parent log, you just switch these. So this becomes half, 1 and 2, and this becomes negative 1, 0, 1. The y becomes x, x becomes y. Then we want to apply the transformation. Transformation is basically the x and the y. So x has moved 2 units back. We talked about that. And y has moved 6 units up. Now let's go ahead and do the calculation. So basically, this one is going to be half minus 2. X minus 2, so half minus 2. 2 minus half is 1.5, but except this is negative. And then 1 minus 2, because x is 1, 1 minus 2 equals negative 1. And then the last is 2 minus 2, which is 0. And then y plus 6. Negative 1 plus 6 is 5. 0 plus 6 is 6. 1 plus 6 is 7. So these are the 3 points that I will try to graph along with the asymptote. So my asymptote is x equals to negative 2. It's a vertical line. So let's go ahead and write this down. When we write asymptote, let's make sure that we understand it's a vertical asymptote, because it's a log. So it's a vertical line. Okay, let's go ahead and plot these points. Negative 1.5 on the x-axis, and the y-axis is 5. Negative 1 is 6, 0 is 7. So how do you draw this? On this side, you want to be hugging the asymptote, getting closer and closer to the what do you call it, asymptote. On this side, it's growing slowly. That's how my graph looks like. Let's go ahead and put in all of these. Domain is, so on the x-axis, it doesn't start till negative 2. Negative 2 not included. On the range, the arrow is going on forever on this side and this side. So negative infinity to positive infinity. Let's look at the limit. Limit as x is going towards negative 2, so negative, so it's basically towards the asymptote. But from the positive side is here. So as you're getting closer and closer to negative 2, my graph is growing, right? Right? I'm sorry. As you're getting closer and closer to negative 2, my graph is actually, as you're getting closer to negative 2, my graph is dropping, because you want to get closer and closer to negative 2, so that here we're talking about negative infinity. And then as x is going towards positive infinity, my data is growing, so that is positive infinity. It's going up the roller coaster, so this is not there, and my roller coaster is increasing from negative 2 to infinity. Remember, you write only the x value, so it's increasing only from this x value to infinity. So we will stop page 1 with this.